Okay, 2.4, more about linear equations. In this section, we're going to develop equations in point-slope form and in standard form. Right now, you folks have seen y equals mx plus b. So now we're going to develop two other ways that you can write the equation for a line. So let's get started. Now, point-slope form comes from the equation for slope, and you saw this before in section 2.3, where slope, or m, equals y2 minus y1 over x2 minus x1. So we take the coordinates of 2 points on the line and plug them in there. We're going to start with that equation, and we're going to take some generic point x and y, and we're going to plug that in for x2 and y2. So what I am actually doing here is I'm going to take this x, and I'm going to put it into the equation right there. And I'm going to take this y, and I'm going to put it in right there. I'm going to leave the y1s and x1 alone. Okay, so when I do that, now my equation looks like this. So here's that x down there instead of right there, and here's the y here instead of y2. Next step is multiplying both sides by the denominator. I don't want to have a denominator. I want my equation, I call it all on the main floor, like all on one line. So my denominator is this quantity right here, x minus x1. I'm going to multiply both sides of the equation by that so that I can simplify it from the right-hand side. Let's take a look at what that looks like. When I do that, it looks a little bit messy. That's okay. We're used to messy. Understanding that this is, wow, that's a really shaky line, over 1, then this will simplify with that. So my reason for that now is that everything is on the same level. I don't have any denominators anymore. Now here is my x minus x1. That was my denominator there, so I multiplied by that both sides. Notice I use parentheses because I want to keep that quantity together while I'm multiplying. Okay. Now, I said switch the sides of the equation. It's kind of messy up above there, so I cleaned it up a little bit here. And I said, let's go ahead and switch sides of the equation. So usually in point-slope form, you have the y's on the left-hand side and your x's on the right. This is any y, and this is a particular point on the line. So if I have my slope, I know the slope of the line I'm looking for, and I have one point that is randomly on the line, I can plug that information in here, and this is an acceptable form of an equation for a line. Now, making this cleaner and prettier for your notes, point-slope form looks like this. So y minus y1, which is a y value of a point on the line, equals m times the quantity x minus x1, and the x1 is the x-coordinate of the point on the line. So any slope and any point, and you can write an equation. Now, you'll have great desire to use distributive property and clean it up and make it look like y equals mx plus b. But you do not need to do that. Point-slope form is an accepted form of writing a linear equation. Okay, so here we go. What is the equation of a line through a point, 7, -1, and a slope of -3? Well, we could use slope-intercept form, but actually point-slope form is way faster. So again, in your notes, and I'm going kind of quick, so you can pause, rewind as much as needed. But here is the formula we're going to use. Y minus y1 equals m times x minus x1. Now I'm going to take my information that I have here, and I'm going to take this x value right here, and I'm going to put it in right there. And I'm going to take my y value, and my lines are going to cross here. My y value is going to go there. And my slope, maybe I'll come around the bottom here, will go in there. So I'm just going to take all the information and I'm going to put it in the equation. So when I do that, now you got to be a little bit careful here, because take a look. You have y minus a -1. Minus minus turns positive, but I took my -3 and I plugged it in there. There's my -7. And so about the only thing I really did was I changed the negative to a positive. And you are done. You don't have to do anything else. So I put my little emoji there, stop, because everybody wants to distribute -3 and clean things up and make it look prettier. But believe it or not, this is a perfectly acceptable form for an equation. So stop there, you're done. No more work. Okay, a lot of times you know 2 points on the line and you need the equation for the line. Slope form is probably one of the easiest ways to write the equation for the line. So I know 2 points, -5, 0, and 0, 7, and my line goes through those 2 points. Now, I need the slope. Regardless of which equation I'm using, I'm going to need the slope. So, and either one of the points. I think I use this one, but you could just as easily use the -5, 0. Does not matter. So first thing we're going to do, find our slope. Now, if you don't remember the formula for slope, write it in your notes. M equals y2 minus y1 all over x2 minus x1. Plugging in your values. The biggest caution here with slope is because you're subtracting here, there's the tendency to forget to subtract the negative here. So again, we can go up here, we can do a little bit of labeling just so this makes a little bit more sense. I'm going to call this x1, this is y1, this is x2, and this will be my y2. And my handwriting is terrible with these big fat pens. That's a 2. There we go. So if you can follow there where these went, so y2 is 7, y1 is 0, x2 is 0, and x1 is -5. So watch the double negative there. Turns my slope into positive 7/5. Okay, so we have our slope now, and we have a point. You can pick either point, doesn't matter. Take either one you want. Let's grab our equation. Y minus y1 equals the slope times x minus x1. And I took the second point. So y minus 7 equals 7/5 times x minus 0. And we clean that up just a little bit because x minus 0 is simply just 7/5 x there. You wouldn't write the 0 times something. So we do clean that up a little bit. But otherwise, that's all there is to it. So point slope form, it's weird when you first get started, but it's super fast and super easy. And it tends to become a favorite of students as they go.